thanks everyone for making it to this talk. I know you have many options, and this is a little out of the mainstream, so I really appreciate it. And hopefully we're gonna have a nice conversation, a small group. I'm gonna share what we're doing at UW-Madison. Okay, 2 hours from here, south. I mean, we're calling this, in general, Day Brain Project. Okay. And probably one of the most important things we have been able to do so far is to put together a nice team of people. And when I say a team, is that we are combining the data science domain with the computer science domain. And actually within the computer science, we have people who are very developed on the area of analytics, and other in the area of database management and database integration, basically. Right? Okay, so everything in between there. We have some people also in both sides, that some computer scientists that understand a little better the data domain, and we have some data scientists that are very well versed on the area of data analytics in general. Okay, so during the past 2 years, actually we were lucky enough to get a $500,000 grant internally from the University of Wisconsin that they call the UW 2020 initiative, and it was trying to attract initiatives like these, very interdisciplinary, in which they can have a little of risk, but on the other side, try to get off the ground project that could have a high impact. And that, I think they bought on that idea. We put together this team. We have a number of students, postdocs involved in this, and at least 8 faculty at the moment. Okay, and actually we put together also a group of people that we call an advisory committee that's helping us to direct this project. We have published a number of different types of papers, mostly abstracts in scientific meetings. And hopefully this year are going to come 2 or 3 papers, scientific papers out of it. And we put together some, what we call prototypes, tools based on the data we are collecting. One important thing as well is we are collaborating with at least 5, what we call top-notch dairy farmers. Dairy farmers in Wisconsin are great because they are very collaborative. When we approach a farmer, they say, take all my data, let us know how we can facilitate this program. So the idea we did at the beginning is try to approach different farmers that would have different technologies. For example, we wanted to be exposed to robotic systems. We have those. We wanted farmers that have a lot of sensors. We have those. We have farmers that have different types of technologies and software. Because the idea of this project, Dairy Brain, is merge all this data together in one place and make it help the farmers to make better decision making. That's the whole idea. In Madison, there is this building that's called the Wisconsin Institute for Discoveries. It is specially designed to promote and nurture interdisciplinary collaboration like this one. And so basically we are housed there most of the time. And in the basement of this building, there is the Center for High Throughput Computing. At the moment, it's receiving all the data we're collecting from the farmers on that place. So we are physically bringing the data to campus. That's what we are doing at the moment. But during these past 2 years, actually, probably the most important thing we achieved was to secure funding from the USDA. So we were able to attract an extra $1 million to continue this work for the next 3 years. And we just started this, which is great. It gives us a lot of opportunity as well as challenges to keep moving forward on this. The USDA has this new initiative that's called Food and Agriculture, Cyber Informatics and Tools, and it is heavily based on what I have been seeing throughout the day here about data analytics, data integration, data management to better decision making overall. And in this case, directed basically to agricultural applications. This is what happens on dairy farms, and we have a dairy farmer here, which is great, and hopefully she will agree with me, that farmers are having all these different data. They are being inundated with data, and these data come from different sources, different software, different companies. We have a robotic system that has a specific software management, And we have another company that's about the feed management, and it's a completely different system. And then there is the company that buys the milk and provides some data back to the farmer as well, and it's a completely different system. None of these systems connect together in order to help the farmers to make better decisions. Okay? If the farmer has sensors, for example, these sensors could give you every minute the activity of the animal, and that can help you, for example, to detect if the animal is in heat, or help you to know if the animal is sick or potentially sick, for example. But there is no way at the moment, or effective way, to connect that with the feed behavior of the animal, with the weather, and with the, for example, what the genetics of the animal is, or genetics and phenotypic behavior of the animal. If we would put all this together in one place, in real time, we are convinced we can do much better decision making and help better the farmers. So basically, farmers nowadays are doing these important decisions based on intuition. Okay, for example, in order to replace a cow, which is a common decision on the farm, we have a capacity of number of animals on the herd, and you sometimes need to make the decision to bring a new animal and get rid of an animal that will become meat, basically. That's what happens. And many times that's done based on intuition, experience, and habit. Okay? Farmers will have good experience, that's okay. But we think if we put together all the data and we actually simulate and optimize that decision, the bottom line will be much better for everyone indeed. Okay? So there is big data, and there is a huge trend. There are several studies that are showing that nowadays, for example, we only have 2% of farmers in the Midwest, in Wisconsin, with robots. But if we go to Netherlands, I think it's 20%, okay? Or many places in Europe, it could be even higher. We would expect that this is going to grow exponentially, and with that, more data, more sensors are going to be available. So there's going to be more need to manage, more opportunities, more challenges in that area. And that's already been seen because there are much more conferences and work based on big data and data analytics on farms, on dairy farms specifically. Recently we host actually in the Dairy Science meeting, the American Dairy Science Association, which is the largest association in the world about dairy. We hosted a symposium that was very successful actually, with a lot of attention in the industry about doing this. In Wisconsin, in Madison specifically, recently we hired a professor who is heavily based his work on data analytics on dairy farming. I mean, the bottom line of this slide is basically there is a lot of attention, and this is gonna keep growing. At the moment, actually, if everyone knows, I'm trying to hire a postdoc that would be in the domain of data analytics, and that individual doesn't need to be dairy scientist. Okay, we have reached the point that actually I'm publicizing that more on the computer science domain than in the dairy science domain. Okay, probably you will find this familiar for those of you who have. Well, we all have nowadays smartphones, but this is specifically an iPhone domain, Apple domain, for example. There is an app that's called Health, okay, and this Health app actually could use different sources of data from all the different apps. For example, if I'm a biker and I have an app that's called Strava, it will record all my bike activity, for example. But I may have another app, for example, that could count my intake of calories during the day, for example. Okay. All this information could go to the Health app and be combined for some visualization, dashboarding, or even some analytics, okay? But the point here is that this happens even with only our agreement of those apps using our data. We don't pay for this. We may receive some benefit at the end, but we don't pay, we pay with our data. But internally, maybe there is a commercial transaction between these apps, app developers, and Apple, okay? And Apple maybe later will sell this information to the Mayo Clinic, for example, Okay? So there is a lot of transactions in the background, and this still needs to run even if we have issues about confidentiality or data ownership issues. Okay, those need to be sorted out, but this is already in the domain and this is working. Our idea, and on that grant I mentioned before, this should work, and it should work even better in the domain of the dairy industry, for example. Why we don't do that? We have different software. They should talk together in order to give a better insights for the decision making at the end. So what we want to develop here and create is a technological foundation for creating this ecosystem of data and services for improving the dairy industry in general. And that obviously will include some level of transactions with APIs to move the data from different sources for different applications, and maybe business to business relationships in order to make this happen. So there is a big need of doing that, and we need to improve the data quality and to create a system in which we can transfer the data exchange among all the players in order to help everyone else in the industry. So basically what we're trying to do here is represented in these four main objectives. So at the beginning, we want to create a group of people. Believe it or not, at the beginning we didn't think that would be that as an important objective for doing this kind of work. In the first objective, we want to create a group of people that we call the Coordinated Innovation Network. A group of people that need to be convinced that this needs to happen, and they need to help us to develop all the way through. Actually, this past Monday, we had a big meeting in Madison, taking advantage that this week happens the World Dairy Expo, you may have known. And so a lot of people from all over the world come to Madison. So we decided to do this meeting. We had about 50 attendees, and we have about 10 attendees online. And those people are the people we are calling the Coordinated Innovation Network. And those are people with high profile within the industry. They are owners or CEOs of these big companies that provide software. For example, Lely representatives were there, GIA representatives, the Laval as well, and they were also from the feed industry, from the software industry, from all those industries. And we were together in a room during all day, trying to work out all these issues of data ownership, data management, data privacy, and how to somehow incentivize the transfer of data among all of them. So that's an important issue we're trying to tackle here. And the next step we want to do is to create this, what we call the agricultural data hub. That's basically collect all the data. We're already collecting the data, but we need extra work to harmonize the data, clean the data, and make it very available for the next steps of analysis that we're calling specifically the dairy brain part. And this dairy brain part basically is to develop decision support tools, okay, that farmers and other people involved with the decision making on farms could use for effective improvement of the operations. That's the bottom line in a nutshell. And on top of that, we have this very interesting extension program that we need to try to work with the extension professionals. I myself, I have 70% of my appointment within extension. Now it's called Division of Extension within the University of Wisconsin. So we try, all what we do, we try to transfer as fast as we can to the final users, farmers and other practitioners who work with farmers. Within the Coordinated Innovation Network, what we want to do is nurture this network of stakeholders I mentioned before, but we want to develop documents. And we want to make these documents available to all those people who could use, okay? I think I have some examples here. One document, for example, would be data ownership, okay? we all can say that the farmer is the owner of the data, okay? And that makes all the sense in the world, but many companies could claim that at the moment they do a transformation of the data, they will become the owners of the data. So it becomes an issue for us to collect all the data in an effective way, okay? A simple example is, if the farmer records the data in the software as a date of birth of an animal, and the computer software converts that to age, that data becomes part of the software rather than to the farm, okay? So all those things, we don't think we are in the position to change how that should be in the industry, but at least we can put our opinion out there and start the discussion on what should be the best way to move around these, I think, contentious issues within the industry and the data to be used for those. Within the agricultural data hub, what we want to do is collect the data that we are doing at the moment. We try not to interrupt or interfere with the normal management on the farm. We just put a computer on each one of the farms we're working with, and that computer connects with us and sends every night all the data we need to our center. But what we need to do after, and probably that takes much work and human power, is harmonize, clean the data, store the data in a way we can use and retrieve effectively later. But after that, also we need to take care to distribute this data for effective use. And this could be through these application programming interfaces, APIs, which is the modern way to transfer data effectively, or we can make available to human users, to the same farmer, right? The same farmer should be able, this has not happened yet, but should happen soon, to log in and be able to retrieve their own data, visualize the data, and do some analysis, or the analysis they would like with their own data, but in an integrated way, okay? So here is the main concept we have behind all this, okay? Maybe it's very common sense, but also it's something that hasn't happened in the industry and probably will not happen still in a few years, and we are trying to push this idea. We will have on the center this agricultural data hub, resides all the data, and it's not only all the data, but the data needs to be integrated, okay? But all this needs to be actually in agreement with the opinion of these documents that are being created with the Coordinated Innovation Network, this group of people that are guiding us, who are external to our own research group, throughout these design documents. Then we have this data, and if the data is in the correct format, and we have all the right analytics, I mean, here we have all this machine learning, artificial intelligence, or very simple mathematical functions, we can have these dashboards for visualization or analytics, as complicated as we will like, okay? But one thing that's new, and actually another important thing here is, none of this will happen if we will not have the agreement of the farms. So it's critical, for sure. But one thing that's new here, and the reviewers on the proposals found very interesting and very important, is the fact that we should make available all this data to other innovators. And these other innovators are other researchers, companies that will have capacity or development on the data or using the data for any other purpose that is not us. And here I refer back to the example of the health app, okay? So we can become the facilitators of a very efficient exchange of data for those people who could provide extra value to those data. We would like to do that, and we will do that as well. But why we close the doors to other people who could as well work on that? Briefly about the agricultural data hub, I mean, there are different ways to do that, and many of you may have some idea, but our computer scientists believe that the best way to use the data for us is first extract, transform, and load. There are several protocols that could be used, but in our case, the idea is that at the end, we will have the same format regardless of what is the software that's collecting the data. Because farmers will have, for example, for collecting and using the data from the feed, for example, there could be up to different softwares, 5, 6 softwares in the industry right now being used, very popular. But the idea at the end is that regardless of the software that collected the data, we should be able to have the data in a standard format for using later. And we can create this, what we are calling data marts, which are what I was mentioned before, be able to distribute different sets of integrated data for different potential innovators who could take advantage of that information. But one important thing of this is we will not be able to distribute this data unless we unlock the data by the owners of the data. And we believe the owners should be the farmers, and that's up to discussion. I believe they are, okay? But also, we will include the opinion and the documents we will be creating with the Coordinated Innovation Network. And this data could go to researchers or could go to industry or any innovator who would like to use the data and provide extra services, for example, to the industry. Ourselves will use the data as well. And we will do this dairy brain for predictive or prescriptive decision making. Okay? So we can do this very sophisticated projection simulation models. At the moment we are very lucky to have all these computer scientists, but we in our own labs as well, we use the data for different types of predictions and using the data. Indeed, over the past, what has happened in our labs is we have collected data from farms, or we put together some research or design research from the farms. We put together the data, we need to integrate the data, we do the analysis, but the analysis ends up there. The idea of doing this is this analysis needs to be on a continuous basis, so the insights remain constant on the farm as the conditions keep changing. And then we will have this decision making at the prescriptive level, because one of our colleagues in the computer science is extremely well versed on optimization development, for example. So the idea is to provide insights beyond of the prescriptive level. And the idea is, for example, create policies that optimize the whole management of the farm, for example. I think we can reach a level in which the decision making needs to be at the level of the whole system of the farm. Historically, in dairy farms specifically, the decisions have been made by management area, in the nutrition area, in the reproduction area, in the health area, but we all know that each one of these areas also affect and are being affected of the other areas. So what we want to do here is effective decision making that is including the whole system on the dairy farm. Here are some examples that we are working on and should be available hopefully soon, okay? And this is what we propose actually to develop, at least in the first phase of this project, ourselves. And there are different types of tools that we are developing, and we classify those by the term that they will help in the decision making. They could be in the short term, the mid-term, or the long term. There is a relationship between the term, how fast we will have the decision making, and how much involved or sophisticated the tools would be. For example, these short-term tools are extremely simple actually, mathematically or with the functions we are going to be using. For example, just calculate the daily feed efficiency of the groups of cows or the whole herd. Mathematically, it's a simple function. The challenge there is to have the pipeline of data flowing, connected effectively to make the calculations every single time in real time for the farmer to use. And this is very effective, very similar with the calculating the milk income or feed cost on a daily basis, for example. Okay? Every farmer will or could use effectively this information to make decisions in the nutrition side, reproduction side, in many areas of management, they need information that has been actually heavily requested by the farmers we are working with, okay? And they may be able to calculate. It will take a long time to put together different spreadsheets that they download from the software, but that should be automatically done by a click of a button, and they will get at their fingertips in their smartphone, for example, every single time they request. But as we go down here, we can use much more sophisticated techniques like machine learning or different types of machine learning, artificial intelligence, in order to make larger decisions, like for example, calculate the net present value of a cow or the problem of replacement of animals in the long term. In this case, for example, we will need to project every single cow in the long term, what would be the profitability of each one of the single cows, and if we need to make a decision of replacement, or if we need to make a decision of treating an animal or breeding an animal, we can make a better decision if we breed an animal with a different type of semen, or if we use a sex semen, or if we use even a beef semen that's very common nowadays in the dairy industry. All those things have economic implications that you don't see today, but you will see in the long term. And in order to see that, you need these sophisticated models and the integrated data flowing at the same time. Okay? Here is a little more examples that I don't want to go into details, but in each one of these tools, the important thing is that we will need different data sources from different software or different systems. And that's the challenge here. And that's the challenge I think we should be able to tackle and improve. Like for example, for this kind of tool, we will have 1, 2, 3, 4, 5, even 6 different data streams that need to be running at the same time, being connected effectively, and then the algorithm will provide the additional value that comes with that kind of integration. And at the end I mentioned, I just have a minute or two, the extension program. I think this is very important. It's not at the end because simply we wanted to put, but we are really actually committed to do this, to deploy all this information to the people who are going to be using. And because of that, actually, we decided to do this, what we call multi-touch, multi-activity this extension program, in which we will have all these seminars, webinars, workshops, and demonstrations on farms for people to be convinced that this is a system that should work. One thing we have in the middle is one thing we are calling data money. So we're going to create in each one of the farms we're working with a team of people that are going to be committed, and we're going to actually nurture that team to be committed to use integrated data for improved decision making on the farms. And with that, I would like to thank you very much for your attention. And if there is time, I will be more than glad to entertain questions. Thanks. Yes.
Could you please share with all of us experience with Nestlé? In general, what is the concept of having big companies involved in your project?
Yes, sure. But there are two. Nestlé is interested on this kind of work as well, very heavily indeed. We do have a large project with Nestlé. They created in China one thing that's called the Dairy Farm Institute, and we have been working with them for 5-6 years now. During all these years, we have been going to China to actually transfer information, knowledge with the Chinese dairy industry, because they need not only more quantity of milk, but more quality. But recently, Nestlé has been very interested on the integration of data from the standpoint of view, not only because of improving the management or the profitability of the dairy farm, but because they want to promote transparency in the selling. So it's basically from the social acceptability of the product. And that's a big deal. Actually, at the moment, they are somehow collaborating with us, but they also have a project somehow similar to this that's called Baila with a Y in Europe. And somehow we're trying to join forces rather than compete. But we are in kind of in a similar position. Thanks. Yes.
Do you work with like Holstein Association as a potential data source, especially
Yes.
on the genetic stuff?
Yes, we do. And the CDCB as well. Yeah, which is the Council for Data Breeding at the US level. Yeah. Yes, we do have. The other source of genetic information is about the genomics ENLITE system from Zoetis. I don't know if you're familiar. It's becoming very, very popular nowadays. Farmers are testing genomically all the calves they born in the farm. And based on that, they select or they have better decisions throughout the life of the animals. So actually from the farms we have, all except one I think have all the genomic tested animals. So all the animals have a genomic test, which is much higher information on the genetic side than just the parent genetics. Yes. Okay?
Can I ask another?
Another question, yes.
Okay.
Sure.
Do you work with various sizes of farms, or do you stick with like the very large farms?
Various size. Actually, our smallest size farm is 120 cows, 2 robots, which happen to be in the Valley. But yeah, and the largest one is close to 3,000 cows. So we are trying to have different size and different types of farms, so we can be exposed to different technologies. We think the concept would work regardless of the size of the farm. Yes. Well, thank you very much.
Thank you.
Once again.